technologies that enable the internet, your iPod and cell phones are driving next-generation transportation infrastructure, resulting in cars and vehicles being able to talk to each other. These connected vehicles will help traffic authorities worldwide battle city congestion, pollution, and reduce the number of traffic-related injuries and deaths. Across the globe, a staggering 1.2 million people are killed on roadways, and up to 50 million more are injured every year, according to the World Health Organization. With connected vehicles, these numbers, as well as traffic congestion and fuel waste, are expected to come down dramatically, delivering tremendous social and economic benefits and raising the GDP of the world's economies. The framework for these vehicles is known as Intelligent Transportation Systems, or ITS. ITS has the potential to improve the way people all over the world travel from one place to the other. Let's see how Intel is playing a critical role in enabling this future. ITS technologists from around the globe recently gathered in Stockholm for the 16th ITS World Congress. Over 8,000 participants were present to focus on the benefits of ITS in people's daily lives and addressed some of the challenges they currently face. The host for the Congress was Ertigo, an organization advancing ITS in Europe by connecting key players and organizations. You may be surprised to hear that the deployment of car-to-car communication is a lot closer than you think. Paul Comfort, Ertigo's head of efficiency and environment, explains how the Cooperative Vehicle Infrastructure Systems, or the CVIS project, is developing core technologies that enable the car of the future to communicate directly with other vehicles, traffic lights, tolling systems, or anything connected to a transportation network. CVIS will provide the capability to inform drivers of the road conditions, traffic, and potential oncoming obstacles they may otherwise not be able to see. The key idea behind vehicle interoperability systems is to offer a number of services that increase safety and efficiency and provide the driver with a variety of information, all delivered through one common technology. Being connected wherever you are will be essential. Future vehicle interoperability platforms, such as the CVIS Open Platform, support different types of connectivity, including Universal Mobile Telecommunication Service, or UMTS, GPS, short range, microwave, and infrared. Knut Evensen, VP of Technology at Q-Free in Norway, explains how the system architecture isolates applications from the communications and technical systems. This allows developers to easily add applications one by one. All of the services we'll see took less than 2 weeks to implement and deploy. Let's take a closer look at the CVIS prototype. Here's the Open Technology Platform for Communications and Positioning. The box on the left uses an Intel processor to perform real-time network processing for G3, UMTS, and GPRS. The other box measures positioning with sensors that measure inertia, among other things, to determine the direction the car is going.
As we are moving as much functionality as possible into the antenna, it is important for us to have a powerful CPU platform inside the antenna. And due to power efficiency, Atom is a very wise choice for us.
The next generation CVIS platform, currently in design with field trials starting 2010, has an antenna and a PC with integrated display. It uses an Intel Atom processor that acts as a complex router for 5 independent radios, greatly reducing wiring costs. The board is much smaller than earlier generations because of the low power and small footprint of the Intel Atom processor and chipset. The combination of the Atom processor and Linux simplifies design and allows developers to easily port to future platforms without sacrificing openness and compatibility. Next, an engineer from Logica will show us how services are implemented with CVIS. Logica is a leading systems integrator that applies the concepts of prototypes developed by the CVIS project across the whole chain of cooperative systems.
This is what we call safe drive. Instead of traffic signs next to the road, traffic signs or traffic warnings can now be shown into the car. You can imagine kids going to school, but not at nighttime and not during holidays. So with the CEVA system, you can have specific time slots where these messages can be shown into your car.
The CVIS open platform equipped with Intel processors makes it easy for the transportation industry to create new safety messages, such as warnings about school zones, passing emergency vehicles, or traffic slowdowns, which will help prevent road accidents and injuries.
Next, we are going to be warned that a wrong-way driver is up ahead. The CEVA system is capable of having lane-specific positioning, so the car is capable of determining when it's driving the wrong way. Not only the driver itself will be notified that he's driving the wrong way, the car will also broadcast this information to other vehicles in the vicinity. As soon as we enter the street, we will be notified of the fact that a wrong-way driver is up ahead.
Applications running on Intel Atom processors broadcast information about stopped cars, train crossings, or other safety-related conditions to other vehicles in the vicinity.
The following application is based on multimodal transport. A roadside unit placed at a train station will broadcast the train schedule. When we get close, we'll be notified of the fact that 2 trains or the next 3 trains will be leaving at certain times, and it will even tell us there's parking spaces available near the train station. This will make it easy for the driver to make a decision. I will park my car here and just hop on the train to get to downtown city.
The reliable wireless connectivity delivered by Intel platforms improves mobile communications and decreases travel time with eco-friendly applications, like advisories to shut off engines, efficient vehicle routing, and smart traffic lights. Technologies such as CVIS will enable greater innovation leading to new applications and services, some of which are yet to be defined. CVIS systems based on Intel processors and chipsets are now on field trials across Europe, paving the way for more efficient and safer transportation. The EU is expected to ratify a directive governing vehicle interoperability in 2010 that will oversee the deployment of CVIS-type platforms across all 27 EU countries. The recent joint announcement by the EU and US to work together on intelligent transportation systems will accelerate ITS technology growth. It will drive Intel architecture-based solutions into all means of transportation. These efforts will help traffic authorities across the globe minimize traffic bottlenecks, reduce pollution, and increase safety. Real progress is being made with system testing underway throughout Europe and actual deployments expected in the next few years. These systems are based on an open platform using Intel processors and chipsets, which enable a cost-performance optimized solution. Playing this key role in enabling ITS is just one of the ways Intel's embedded group is tackling some of society's biggest challenges head-on.